All right. Has everybody? Edward has announcements.
Oh, okay. Hi, welcome. Thanks for coming to the meeting. Few things before the meeting starts. Our student project funding, little site, little one page up. So if you have a project you want to get funded with, you pull up the website. We'll show you.
Okay. Oh my gosh, electronic.
Don't forget to vote also, the upcoming elections. So here's our main website. Scrolling down here, student project funding rules takes you to a Google Doc with all the rules for the acquisition proposal, and all the way down to funding, usage, services, project updates and acknowledgements and stuff. So I think around $200 is available for students this semester, or 100. It's 200 now. So $200 are available, but it's a pool, so everyone has a split and stuff. But it depends on your proposal, how much you need, and everything else, and budgeting stuff. So that's the first announcement. Second announcement is Hack.io is this weekend. If you're not participating, you can volunteer for us. Later tonight, I'll post a link in the Discord where you can apply to volunteer for specific positions at Hack.io as a regular volunteer or our volunteer, because we have a table there that we use to lend out parts to students. The whole reason is that currently eCouncil does things for about $200 an hour per volunteer hour. So that'll get us a lot of money for more student project funds, more PETs, more things, discs, and just more materials and cool equipment too that we can buy that'll make the workshops more enjoyable too. But yeah, that's all I had. Any questions, comments, concerns? Awesome.
All right, so yeah, there you go. All right, so this is gonna be the introduction to Raspberry Pis. A lot of people are like, you can look up anywhere on how to code a Raspberry Pi, how to get the GPIO to stuff to work. So I'm not really gonna dive more into that. I'm actually gonna go more into controlling a Raspberry Pi remotely. So you don't actually have to plug the Pi into a monitor and keyboard and code on it directly. You can actually code on your computer and then upload your code to the Pi, which is a lot more like easy to work with. And so that's what I'm talking about with control with SSH. First, just general contact info of all the different officers. You see Edward Louis was the one who just talked. Connor Behite. I'm the treasurer. Chris Murray is not here. We got a webmaster. I think he said he wasn't going to make it today. Yeah. And then SV. I only know you by SV. I can't say your name. However, he said that. You can join our Discord server. You can, I don't expect you to copy the link, but you can look at our slides online. Speaking of, go here and you'll find our slides. I saw there was already a few people on here looking. You can just follow along. It's mostly gonna be pictures, not much text, because I'm not trying to do code. I'm trying to teach you how to do things. If you could do attendance, please, that'd be amazing. I'll leave this up for a few minutes so that people can get their phones out and scan it. All right, it seems like most everybody scanned it. If you haven't, you can go on the forums or on the slides and click on the link. All right, so we're going into Raspberry Pis, so might as well start on a little bit of history. You can see we started with the Raspberry Pi 1, had RCA video, bigger jack, and a lot smaller GPIO. Then they realized, hey, people don't really use RCA, so they switched to HDMI, or they got rid of it and switched mainly to HDMI, added more USB ports, added more GPIO. Raspberry Pi 3 added wireless connectivity, faster processor, obviously. And then onto the Pi 4, more HDMI ports, but there's mini now, USB-C. And then obviously around it here, also around this time frame, they've had the Pi 0, which got rid of a lot of features like the USB ports and stuff like that. But yeah, is there any questions on history? Not really that much information besides generally that's how it progressed. That's for you to figure out. That's actually part of the challenges. All right. So we have a lot of Pi 4s that we can actually lend out. If you want to use a Pi 4, just ask us and we can get you one. Obviously you have to return it or buy it. But yeah, so a lot of Raspberry Pi has been stuck, or I guess go top to bottom. Fast processor, quad core, pretty cool. H.265 hardware decoding. And then Raspberry Pi has been stuck at 512 or 1 gig of RAM for all these years. The Pi 4 can go all the way up to 8 gigabytes of RAM. So you can do RAM intensive things if you want. Ways to program on the Pi. You can either program it directly with a monitor, keyboard, and mouse. That's the part that I don't really like doing. SSH into it and code in Nano, which is what I'm actually going to teach you to do. And then what another way I do it is I actually write the programs in like Notepad++ or actually in a Python environment. And then you can actually upload the files to the Pi and then run it. That one I'm not going to teach you, but if you have questions about it, I can teach you one-on-one. All right, so we're actually going to start with, if you were doing this from the very beginning, just you've got a Pi, you have nothing on it. So the way for instance, how I set this Pi up in the front here. I went to the Raspberry Pi website down at the bottom there. Just went down, went to download an imager for Windows. This is what the imager looks like. You're going to click on choose OS. And then if you're doing what I'm doing now, which is running it without a desktop environment, like if I wanted to plug a monitor into this, I actually couldn't because it's not outputting a video signal. That's because I chose this Raspberry Pi OS other, and then I chose Debian Lite. So it's basically Debian without the desktop environment. So that actually frees up a lot of the processor in order to do more code things. You know, you're not wasting time on generating video and generating a desktop environment and all that. So that's how we got there. So we now chose our OS, choose our storage. Obviously, you choose your SD card. I only had the one in there, so I got to just click the one. Then we chose our storage, chose our operating system, click write. It's like, hey, do you want to erase all your data? Yes, I do, because I want to actually install this. So it goes on to writing. Mostly this is as reference. If you want to do this yourself at home, you can pull up the slides and do it yourself. Did you have a question? Yeah. Like let's say anything that was on the SD card's gone. Like if you had anything on the like maybe you're using it on your Switch and you had some games on it or something like that, they're gone. So basically it cleared it out and now it's installing an OS onto it. And that's what this writing is doing. It's writing all the files and stuff like that. After it's done writing, you will have something that looks like boot and then a drive letter. This is actually part of the file system. It's not all of it. You know, you saw it was a 32 gigabyte SD card. Right there, 32 gigabytes, but we only actually see 250 megabytes. That's because Windows actually doesn't know about the other partitions, or it does know about them, but it doesn't assign a letter to it because there's no point in assigning a letter to it because it wouldn't really be able to read the files anyway. So we're actually going to go into this. We would create, this is what it looks like. You can see it. We would right click, create a new text document. And then we just name it SSH. This is basically saying the reason why SSH is actually not enabled by default is it'd be a huge security risk to have a whole bunch of Raspberry Pis just on the internet with default usernames and passwords. So they actually just disable SSH by default. And so this is our way of enabling it without actually booting the computer, because we can't use the computer without SSH, and we can't use it, or without SSH, we can't use it at all because we don't have monitor and keyboard. So that's how you will enable SSH if you were doing this yourself. Obviously it's going to say it's not a text document anymore, it's just a file. It actually doesn't have an extension, it's just SSH, that's it. And so it's saying it might become unusable. You said yes. So then you eject the SD card, and that's how you create a Raspberry Pi bootable from the beginning. I know we didn't have actually any hands-on things, but honestly I feel like it wouldn't be super useful to have people create a whole bunch of Raspberry Pi bootables. But is there any questions with how that worked or how that would work? It's not too bad. Yeah, you have a question? Um, oh, I guess we kind of could have started with that. All right. Do you know, does everybody, all right, who doesn't know what a Raspberry Pi is? I am so sorry. I guess I just went blazing right into it. All right. I'm so sorry for just blazing right into it. I guess I just assumed that people knew. This is what Raspberry Pis look like. Here's one right here at the front. You might not be able to see it because it's small. This actually is a computer, just like something similar to your phone, but it doesn't have a screen. It doesn't have, that's actually about it compared to your phone. It has about everything else. Oh, I guess it doesn't have cellular connectivity, but basically it's a computer that you can run code on. And then you can actually change these pins just like an Arduino. Who here knows what Arduino is? Everybody? I don't have to explain Arduino. Yeah, Connor? Great question. Thank you for asking. So Arduinos are called embedded systems, which basically mean you upload your code and that's all it ever runs for the rest of its life until you re-upload different code. This is different because it can actually change its own code because it's a computer, right? A computer, theoretically, you could program it to change how it acts based on external environments, or like it can also reprogram itself, right? You don't have to plug this into a computer to program it. You can actually just program it within itself. And then that's why it's not an embedded system. It's actually like a regular computer, I guess is how I'm trying to say. Do you have any other good questions, Connor? You're actually doing a great. Okay, thank you. I've actually seen them used a few places. Actually at Ohio State on the Reddit, at one point somebody actually posted a Raspberry Pi and like they found in the library and they had no idea what it was. And one of the comments was, "Hey, that's a Raspberry Pi. Please don't touch it. That's my project." It was actually keeping track of all the different Bluetooth devices that came in range as a way of measuring population of like the library. So it allows you to create small little projects that you can kind of place places or put places. It also is, because it's a powerful computer, relatively speaking to the size, you can do vision processing on it. So I've seen people put Raspberry Pis on drones and then use that to be able to do onboard video processing for like trying to land at targets or something like that. That's generally like the use cases of these things. It's just like high performance, but in a small package. All right. Any other questions? Perfect. I'm glad. On this one, it's right there. On this one's right here. On this one, it's right here. On this one, it's right there. And on this one, it's right there. Let's see here. Yeah, so that's the Wi-Fi. That's the connectivity module on these ones. Remember I said I added Wi-Fi and Bluetooth? It's on here and here. And then right here is USB control. I think it also connects to the Ethernet port. Here's your power regulation circuitry. Same thing over here, power regulation, control for these things. I think this chip is RAM. It looks like a RAM chip. It's a RAM chip. I got confirmation. It's a RAM chip. They all look very similar because it's an iterative design. They're all based on the last one. Yeah. So, so you know what Arduino is, right? Like perfect. So Arduino, let's say for instance, for this, the modern day Arduino, where was it? Modern day Arduinos run at 16 megahertz, right? And have like a few kilobytes of RAM. The newest Pi 4 runs at 1.5 gigahertz, so like way faster, way faster, like orders of magnitude faster. And then obviously lots of more RAM. So it's more like an Arduino is like you upload code and it only runs that code. It can do nothing else, and there's no way of changing it. It can't change its own code. Unlike a Pi, it has a full file system, just like your computer, right? Like you can open a Word document. You can actually do the same thing on these. You can open a Word document and start editing on it, just like a regular computer, because that's what it is, a regular. Compared to Arduinos, like I said, they're embedded. They have a lot less functionality. That's the difference. A lot more functionality on this thing. What'd you say? Perfect. What were you saying? That is great. Thank you so much. So the thing that comes with being more complicated is that you have less control over it. So let's say you're doing very tight timing. Man, maybe like for like maybe you're creating your own data signals or what's it called? Communication protocol. Let's say you're creating your own brand new communication protocol, and you need to have direct control at exactly when pins need to change from low to high or high to low, or like direct like individual clock cycles, right? So let's say you need to go high for like 3 clock cycles and then low for like 4 clock cycles. You can do that in Arduino really easily, but you cannot do it at all. It's impossible to do on a Raspberry Pi because it's not an embedded system. You don't have direct control of the CPU. Unlike on an Arduino, you do have direct control of the CPU. That's another great difference. Did that answer your question? I'm glad. What do you mean? That's the whole thing. That's the complete difference. You cannot make it like that. It is impossible to make it that you can count clock cycles on this thing because it has so much overhead. It's so much more complicated than Arduino. Like you have to be like the only person that could do that is the one who designed it because it's just so complicated. And even still, he would have a hard time, or she. I don't know who it is. All right. Any other questions? Feel free to raise your hand because I kind of went too fast. Yeah. Depending on the brand, but yes, Arduinos are cheaper because they are less complicated. You could I think official Arduinos are still like 20-30 bucks, which is stupid. Yeah, that's true. And that's like $4. Did you have another question? Versus a Pi? Like I was saying before, like tight timing stuff, like creating your own data protocol. Or yes. I just thought about it. Let's say you just want to flash an LED, right? You just want to turn it on, turn it off. That's actually, for this, you're gonna have to go through that entire process of what I just described and more. The rest, you're actually gonna have to go through my entire slides in order to be able to flash an LED on and off. That's actually what the end of the slide is gonna be. But for an Arduino, you just install the software, write the code, and upload it. Like it's just a lot simpler to do, and a lot because you have so much more close control over it. Like I've been saying this entire time. Arduinos are a lot simpler. Do you get why? So, well, I'm trying to think, like, because in Arduino, you just write the code and then you upload it. Like there's nothing else. But with with the Raspberry Pi, you have to go through all of this in order to actually be able to run any code. And obviously that's a lot more complicated and a lot hard. That's like the main difference. If you have more questions, how about that? All right. Any more? I'm glad to keep going with questions. All right. So we have SSH. We have installed it on the SD card. We enabled SSH. Now we're ready to actually boot it up and plug it into a network, which is what I have here. A Raspberry Pi that's booted and plugged into a network. So this is where I want you guys to get out whatever device you want to connect to it with, because I'm actually going to have you connect to this Raspberry Pi at the front. Oh yeah, there's one on the ceiling we used last time. Is there really not one anywhere else? What are these things plugged into? There's one. You can sit, if you want, you can sit at the very back. There's one right here. Oh, that's gonna be hard for you to read. Yeah, this room does suck. Nope, I don't think you're gonna have problems with M1 WAC. All right, so I want everybody to, oh, did I really not? So no, I want you to go into a web browser. Well, and then I want you to connect to the Wi-Fi network that's being broadcast by this Wi-Fi router, which is called electronics. and it should be open. Perfect. Then I want you to go to 192.168.1.1. Yeah, I guess I probably could have should have did it. I'll zoom in. That works. All right. So, and then go on a Wi-Fi, go on to like Safari or Chrome or something like that, and go to that. And you should be greeting with something that looks something similar to this. And this is as if you are like connecting this at home. You would do the same thing, except maybe you replace this one with a 0. This might have to be a 0. Yes, those are all periods. Are you seeing it?
Yeah, I
Nice. I want to see, do people see that? Perfect, people are seeing it. Good. All right, then next step, we're gonna look. This is actually my house. This is what my house looks like. You can see we got my Roku, we got a Chromecast, and this is what you'll see if you do this at your own house. You'll see all the devices connected to it. We got my Roku, we got my phone, I think, we got our Roku TV, we got an iPad, we got a Windows computer. There's another phone, there's some smart outlet, smart bulb, right? But the main one we're looking for is one that's called Raspberry Pi, because that's what we're trying to connect to. And you probably will see something similar on yours as well. You might be able to see the Raspberry Pi, and maybe you'll actually probably see the other people connected to the Wi-Fi router. Go down. There you go.
Oh.
So you see Raspberry Pi, you can see Boba Fett, you can see some other Windows computers. Those are all the people connected to it right now. All right. Then copy the IP address of the Raspberry Pi, because that's what we're going to use to connect to it. That's like, does anybody not know what an IP address is and what it does?
On the internet.
All right, I'll quickly explain it. So basically, every single thing connected to a network needs to have an identifier of what it is, because people need to connect to it. So it needs to be known what it is. And that's what an IP address is. I don't actually remember what it stands for. Probably Internet Protocol, which is similar. Yeah, kinda. It's close. That's if you want to think about it, yeah, kind of like a social security number. All right. So now you have the Raspberry Pi's IP copied. Does anybody have not gotten there yet? Please speak up, because I will continue and you'll be left behind. Which Wi-Fi network are you connected to?
You were on it.
Go to electronics. I wouldn't do that, but it doesn't matter. Now, when it connects. There you go. And then scroll to the bottom. And you should see Raspberry Pi, and then copy the IP address of it, which is that one. Yeah, copy the IP address. Okay. And so this is the IP address I'm talking about, right? So in this case, I would copy 192.168.186, but that's going to be different on this one. All right. Now we're actually going to plug it into SSH. So now we have the IP, the Pi and its IP. I'm going to quickly explain what SSH is. SSH is creates a secure connection to another computer, even over unsecured networks. This was, I think, invented like the 1990s, 80s, around there. It runs on port 22, if you're interested. If you want to learn more, you can obviously go to the Wikipedia page for it. But like I said, it allows you to connect to another computer securely. You actually can do it on Android and Apple phones. They actually have SSH clients for your phone. If you didn't have a computer, you can pull your phone out, but it looks actually like most people have their computer. With a Mac, you're going to type something similar to this. You're going to go open the terminal. Let's see, we have what, 2 Mac users? Although he's already ahead. You're going to open the terminal. It's actually going to be the same thing as on Windows. But you're going to type SSH and then pi at and then the IP you copied. Yep, I'm sure. It's built into macOS. So like I said, between Windows and Mac, it's the same thing, except it's command prompt instead of terminal. Does everybody know how to open a command prompt? Go Yeah, just type command prompt. There you go, right there. Yep. Yeah, hit enter. Perfect. You're already ahead. All right. Does everybody have that typed in? Maybe even hit enter? I hear somebody's mad. Are you mad? That was you? All right. Yeah? Yes. It's gonna be the same thing. SSH, I think, is built into all computers at this point. Well, knock on wood. All right, so we'd look something similar to this. And then you'll see the key is this. Are you sure you want to continue connecting? This is actually a good thing because that means it's working. If you cared about internet security and all that, you compare this key to what the actual computer you have is. But we know we're not even connected to the internet, so we know the only SSH server that's running is going to be on that Pi. So you can just type yes. It adds it to the known local host, so it actually won't ask you that again because it knows that you care. It knows that you know what it is. It's not going to ask you again. That's redundant. It's going to ask for the password. Does anybody know the default password for Raspberry Pis? Yes, it's Raspberry. I lost it when I. Yeah, Rasp and then Berry. I actually used to have it typed on here, but then I changed the slides. Oh yeah, sure. Has everybody gotten?
It doesn't show it. It's a
Oh, yes. It won't show that you're typing, but you are actually typing. Yeah, it's a security thing. It might not look like you're typing, but you are. Yeah, you can't see if you spelled it wrong. It'll tell you, but you won't see it. Oh yeah, perfect. That's what you're supposed to see. What do you have? Oh, perfect. I'm glad that everybody's figuring it out. Okay. Then, has everybody gotten into the Pi? Perfect. So you are. Well, he's helping him, right? All right. So everybody is. You actually right now you actually have a remote connection into the computer. Now everything you type is actually being run on the computer and then sent back to you. Yes. The command again. It's just. Let's see here. Actually, you can just go there. You just go there. Oh, that is something you have to do. Yeah. You have to be in command prompt. You have to run it from command prompt. I'm guessing you're running it from run. Yeah. So, delete that, and then type CMD. Enter, or just hit open. Paste it into there, and then run it there. Oh, and then are you connected to the right network? Oh yeah, that's it. I guess you wait while it's. Oh, you don't want to do that though. Right click. When you select, you actually pause the program. All right, I guess you just wait.
easy peasy. Just enter the IP anyways. Pick up.
Oh, so it was 134. Yeah, you have your IP wrong. It's 134. So hit up, just hit up, and hit type 4. 3-4. 1 3 4.
Wait, it says.
There you go. There you go. To be honest, I don't know because I don't use these. But I believe in you. I believe in you to fix it. All right. So sorry for taking so long. What's up?
That first IP address. That's the IP address.
This router. Oh, so yeah. What were you saying? So just quickly, if you care, this is the IP of the router. What you just did is you looked up what this router assigned to the Pi, and then you visited the Pi. So you asked the router, hey, where's the Pi at? The router's like, it's here. And then you went there. Like you basically looked it up.
Just have the Raspberry Pi handle that.
Barely. No, I mean it's just the way it's coded well enough that I mean people who design the software were.
Will it run order?
Yes. As you type stuff, it's basically like your remote connection to it is like live. So as you type stuff, it gets sent and then it sends back a response. And it gets sent and sends back a response. So it's in like real time. All right. Any questions before we continue? All right. So this is what you're greeted with, hopefully. Hopefully you see this right now. Just to quickly explain some stuff. This is your usage terms and conditions. So like it's free software. You can look at it in this file if you want. There is no warranty. You know, like if you screw it up, it's on you. It's not on us. It also tells you the last login. So if somebody else logged into your stuff and you're keeping track of that, theoretically you can see like hackers. In theory, doesn't always work like that. And also notice SSH is enabled. The default password has not been changed. This is a security risk. This is actually absolutely true. This is what I was talking about earlier with SSH being enabled and having all the default stuff. If I were you, I would change it, but I'm not you. And you shouldn't change it because you'll kick everybody else off. So don't change the password. And then also Wi-Fi is being blocked by RF kill. That means that there's no Wi-Fi on this thing right now because it's plugged into Ethernet. So I'm pretty sure the reason why I killed its own Wi-Fi is because it's connected to Ethernet. I'm not actually completely sure. And then also use Raspi Config to set the country. So but before you can start using Wi-Fi, the Wi-Fi needs to know how to communicate, and that changes based on the country. So you have to set your country before you can enable your Wi-Fi. All right. Like I said here, change your password. It is very important to change your password. Because it's, like I said, look at the last slide, pointed out, default password, security risk, blah, blah, blah. I've lectured enough about that. However, you can change your password by typing sudo raspi-config. That's giving me an important command I'll show you in a second. Right here, this is what Raspi Config looks like. You can actually run this command yourself, and you'll see the same thing. But basically, it talks about what the different ways you can configure the Pi. It's super useful if you want to disable your audio, which is useful. Disabling your audio, you have to use PWM ports. That's stuff you can learn on your own. Just 1 second, and then you can also change the display outputs. You can change the time. There's a whole bunch of stuff. You can flip through it if you want. All right, question. Oh, right here, sudo raspi-config. So I'm going through how you change your password. You click on system options, click on password. You will not be asked for a new password. Don't do that though, because we don't want to change the password right now because it'll kick everybody off, like I said before. All right. So now that we are in Linux, we are not using Windows anymore. We're actually typing in Linux directly to the Pi. There's a few Linux commands that are useful. You have list directory that basically lists out all the files. Again, you can do this on your own as we go through the stuff. You can kind of play with it. Change directory, and for instance, cd ... basically it allows you to go up and down and move around the file system. So let's say you type ls and you see some folders. Actually, I can just show you. I can't because I would have to disconnect from the Wi-Fi and that would skip the Zoom recording. I can't show you. But basically, you can type ls, you'll see a file, or you'll see a folder, and then you can change into that folder. Or you can go cd ... and that goes up a folder. So it's just like how you have C users, your username, documents. You can go up and down that folder structure within Linux. Nano is the text editor. Is a text editor within it. Think about like Notepad in Windows. Nano is a way to edit text files. You have copy, move, make directory, remove directory. Oh, goodbye. No, the mouse is fine. Move directory and then remove. Basically, that's just how you can make and move files, make and move directories as well. Sudo, which stands for super user do. Basically, in Windows, that's when it asks if it wants permission to make changes to your hard drive. You get yes, no. That's kind of the equivalent of like elevating yourself to make you be able to do stuff. And then cat is just show a file in the terminal. Nothing super fancy. It's kind of like Nano, but simpler. All right, and then I've always liked the questions, how do you shut down your Raspberry Pi? If you don't do it, but if you wanted to restart the Pi right now or shut it down, you can type those commands and it would shut down or restart the Pi. Don't do it though, because we're not trying to do it. But that's how you would do it, is you type these commands in there. The reason why you do it is because it's a proper operating system, just like Windows. You obviously don't want to just unplug your Windows machine. Same thing, you don't just want to unplug it. Any questions with what I've gone through so far on like basic Linux and stuff like that? Great. All right, now that we're here, lastly, the main thing you program in here is Python. That's how you generally run Python, or this is how you run Python programs that you write in. You have to remember to specify the path to the program or be in the directory. By that, I mean, in your terminal, you can see a path that you're currently in. Most likely it says pi at IP and then like a little squiggle thing or something like that. That's your current directory. That's where you're actually running all your files. If you have problems with it, just ask me. I can explain a little further. It's kind of hard to explain without being able to show you, and I can't show you. But basically, you would change what's before this program .pi to define your folder of where you're going at. Like I said, I'll show you if you have a question. All right, so this is kind of where I wanted you to connect to the whip, but I did it earlier because I felt like it was super useful. So, like I said, there's a Raspberry Pi connected to this network. Please don't modify any files you didn't create because it was screwed up for everybody else. And then don't do anything that would affect anybody else's connection. I've been saying this entire time. So, challenge 1, I want you to figure out what kind of Pi is at the front of the room without looking at it. Don't say it, because you probably already know. One of the commands I showed you does tell you what kind of Pi it is. Oh, that sucks. Well, you got in there though, so that's good. There you go. Good job. And now you can go into channel 2 if you want. Yeah. You hit enter. Yep, there you go.
But like, do I take the number for?
You just hit enter again. Oh, you can go up and down. And then you can hit enter on the one you want to hit. Hit escape. So have you figured it out? Are you not even going to come along with us? Oh, do you not have this here? Let me go back to the common. Well, no, never mind. You want to, okay. You're trying to type sudo raspi-config. Dash. Yeah, there you go. That's what you're trying to run. Yeah. Mm-hmm. Nice. All right. Sudo space rasp pi.
One word.
Get rid of the extra p though, and then dash config. There you go. What about it? Oh, thank you. I love it. All right. Is anybody stuck that wants to know a hint? All of you are basically looking at it, actually. It's at the top left of your screen. Yeah, it's a Raspberry Pi 3B Rev 1.2. All right. Very top left at the very beginning of the screen. Right there. All right. So challenge number 2, there's actually a little red LED soldered to this. I want you to try and light it up. There is a program on there that I wrote that lights this LED. I want you to find it and run it. Oh, there's one. Somebody did it. Was that you? Nice. It's not going to be in the config program. So hit escape until you get out of it. Oh, there you go. You just did it. Yep. Just hit up. Yeah. CD. And then you just type it. Yeah, there you go. Not a Python program. You have to start with Python. Yep, that's it. Yeah. Don't worry. Oh yeah, there you go. You did it. Good job. What's up? You typed Python twice. Oh, I see. You're in the wrong directory. You gotta figure out what directory it's in. All right, then just to keep going on, everybody knows this challenge who's currently on it. The next challenge is create a folder with your name.number and write a program in it that turns the LED yellow. Yeah, you're still on this one, right?
Yeah, as like a type LS.
Yeah,
wait.
it has a space in it. You notice how there's quotes around it? That's important. You gotta type it exactly how you see it. Oh, you changed the pins. Yeah, it's on one of the. You might want to recopy tests. Yeah, there you go. So you're right now you gotta light up both of these at once. So how could you light up both of those at once? Because that's the correct pin number. Those are the correct pins. Oh yeah, sorry, hi. Yeah, just like that. Except you want to, so here's what the thing is. Somebody's probably playing with that program. And so you might screw up whoever's doing that. So create, delete out everything there. Type mkdir for make directory, then space, and type your name.number. All right, perfect. So now you create a directory for yourself. Now I want you to copy, so cp, then space, and then type test.py. Oh, .py, there you go. And then space, and then type your name.number, and then slash, and then the other one, and then test.py. Hit enter. All right, so do you know what you just did there? Yep, exactly. You made a folder and then you copied it. Give me 1 second. All right, now type ls again. You might notice you now have yours. Now you can cd into it. So type cd and then yep. And now type ls and there's the file you just copied. So now you can type nano test.py. There you go. So now this is your own personal one you can play with.
Need the copy. I had it saying
All right, so you're good?
I knew V was a text editor, but I have
Vim?
no idea how to. I just did VI.
Oh, okay. Yeah, sure.
But I have no idea how. Is there a command to exit?
Probably Command C. Oof. By clicking. Oh man, I have no clue. No, there's not. Yeah. You might want to look it up on your phone or something. Worst comes to worst, you can just close the app and then open it again and it'll reconnect. That's probably gotta be the easiest for you. How are you doing? You want help? All right, so which challenge are you on? All right, so you're trying to just light up the LED red. So type so first type ls. Oh, you did. So these are the different things that are in this one, right? I'm guessing, well, I'm going to tell you, the program that you're looking for is in Python programs. So you type cd. So you're going to go into that folder, right? So that's change directory, and then type it exactly how it is there. Yeah, the quote mark too. It's because it has a space in it. All right, so now you're in Python programs. Type ls again. So these are all the things that are in Python programs. You can see a few people that have created for challenge 3, created their name.numbers. But you actually just want to run test.py. So type Python. And then type test.py. And then now look at the Raspberry Pi while you do it. Hit enter. There you go. See a little LED tar light up? Yep, it would just keep playing. Oh, somebody else is playing with it too, though. But you can see how it works, right? You can see remote controlling it. So now if you want to go into challenge 3, you'd have to create a directory with your name.number and then copy paste the file, which I do explain earlier in the slides. You are in the directory. What are you trying to do?
Well, flash the green light up there.
All right, so you have to edit test.py, but don't do that because you would screw it up for other people. So you have to create a name, a directory with your name.number. So mkdir and then your name.number. Hit Control C a whole bunch. There you go.
And then I just do like CD. I guess it's probably
Yep. Yep.
Okay, and then from here I put it in.
Are you still doing challenge 2 or are you going to 3? All right, so then if you try to do challenge 2, back all that up. Type ls so you can see what's inside this. So you can see a few people have created their name.numbers. But there's also test.py. And that's what you're looking for. So you're gonna backspace that. You're trying to just run test.py. So type Python, because it's a Python program. You have to type Python first, and then type test.py.
Oh, tell you right.
And then what you just did there, you flashed it red.
Oh,
If you do it again, you can flash it again. You can also just hit up and it copies your S command.
Fine.
But yeah. There you go. If you want to move on to the next one, type mkdir and then your name.number. And that's going to create. So now type ls. Now you should see yourself in there. So then you can see and then now go back in the slides and you can figure it out. But you can copy test.py into your own folder and then edit it from there. Yep.
How do I get to the slide? Really?
Type electronics. Well, actually, okay. There is no such thing as a yellow LED, but you combine red and green to create yellow. You can make it just green if you want.
Where are you from, by the way?
Toledo.
Oh, Ohio?
Yeah, Toledo, Ohio.
You said something else before, like yourself. I thought that you meant.
Oh, no. Yeah, that's yellow. I think I can get lit. Let me double check here. Do it again. Oh yeah, that's yellow. Good job. That's the end of the slides for today. Yeah, that was the best MacBook. The new one looks great. The new Pros. Yeah, literally. Yeah, I'm excited for it as well. What do you think about the notch? I hate it too. You don't care?
It's a bar, like everything. Yeah, I did not ask me how you got out of this last time.
Control X. Or Command X maybe. There you go. Don't edit it though, because you'll screw it up for everybody else. You gotta copy it first. Yeah, I know. All right, I think I'm going to end the recording. Now that we've gone through enough questions. Whoever has ended recording. All right, we will end recording.
How long is it recording?
It actually hasn't ended yet. Boop.